All right, anti-forgery tokens. What are they? Well, here we have a security hole in this form. I'm going to open the Chrome Developer Tools, Network tab. Now I'm going to click the Save button. Okay, here's our request. So this request is an HTTP post request going to this endpoint. And if you scroll down, you can see the form data in the body of this request. So customer name, membership type ID, and so on. Now imagine the user who is responsible for creating a customer leaves the site without signing out. So this user has an active session on the server. So they're still authenticated for a few minutes. The default setting is around 20 minutes, but of course this can vary from one application to another. Now imagine I'm a hacker. I can trick this user to visit a malicious page I have created. On this page, I can put an image or an iframe and write a little bit of JavaScript code. So when the page is loaded, it will send an HTTP post request to our endpoint. What do you think is going to happen? Because this user has an active session on our website, this request will be successfully executed on his behalf. We call this kind of attack CSRF or CSRF, which stands for cross-site request forgery. So the hacker forges a request on a different website. And with this technique, they can literally execute any actions on behalf of the victim. In this example, a hacker can create or update an existing customer, and later on, when we implement rentals, a hacker can actually create false rental records. And interestingly, if you look at the logs, all the requests appear as if they were legitimate requests came from the user's browser. We won't have any records of the hacker, their IP address, and so on. So how do we prevent this? Well, we want to make sure that this request only comes from our customer form, not from a different website. So there are two steps we need to follow. In our customer form, we use another helper method, html.anti-forgery token. This method will create a token, which is like a secret code, and then put it as a hidden field in this form and also as a cookie on the user's computer. Now let's see this hidden field and the cookie in action. So save, back to the browser, we go to customers/new, right click here, inspect. So here's our hidden field. It's called request verification token. And look at the value. It's a long, weird string. Now this value is also stored in the user's computer as a cookie in an encrypted format. So let's go to resources, open up cookies, localhost, and you can see here we have a cookie by the exact same name, request verification token. And this value is the token in an encrypted format. So we give the user a token, and when they post a form, we're going to get these two values, the hidden field and the encrypted cookie, and compare them. If they match, that means this is a legitimate request. Otherwise, it's an attack. Because if the hacker redirects the user to the malicious page, they don't have access to the hidden field in our form. Because this hidden field only exists when the user actually visits our customer form. So even if the hacker steals the cookie, they still don't have access to the hidden field. So on the server, we do this validation. If these two values don't match, this is an attack, and we immediately stop the request. Now to perform the validation, we decorate our save action with validate anti-forgery token. So all the complexity of generating a token, encrypting it, validating it is done by MVC framework. We don't have to worry about it. We just have to remember to apply this attribute on our action and use this helper method in our views. Now, build, back to the browser. Now, before saving, I'm going to modify the value of the hidden field to simulate a situation where an attacker doesn't have access to this value. Now let's see what happens. We got an exception. And this is how we prevent CSRF or CSRF attacks.